In Lesson 2, we're going to be talking about conditional statements. A conditional statement is a statement that can be written as an if-then statement. And typically when they're talking about an if-then statement, they're going to refer to the hypothesis and the conclusion of those statements. The hypothesis is the phrase immediately followed by the word if, and the conclusion is the phrase immediately followed by the word then. And symbolically, they represent these with the letters P and Q, where the hypothesis is the letter P and the conclusion is the letter Q. You can see over here, if I had this in a Venn diagram, that my hypothesis is inside my conclusion. I also write it symbolically with a little arrow. If P, then Q. So part of what we're going to do is we're going to look at some if-then statements and we're going to identify the hypothesis and the conclusion. So in example A, we are going to underline our hypothesis and circle our conclusion. If we take a look at number 1, it says, if today is Thanksgiving Day, then today is Thursday. Well, our hypothesis would be today is Thanksgiving Day, and our conclusion would be today is Thursday. Sometimes you have an if-then statement. It's not necessarily in the order of if-then. As you look at number 2, it says a number is a rational number if it is an integer. In this case, my hypothesis comes at the end of my statement, and my conclusion at the beginning. Number 3 says a number is divisible by 3 if it is divisible by 6. And again, it is divisible by 6 being my hypothesis. My conclusion, a number is divisible by 3. The conditional statements can be written a couple different ways. You can see in the middle, we talked about writing them if P, then Q, but they can also be written if P, comma Q, Q if P, P implies Q, or P only if Q. Many sentences without the words if and then can be written as conditionals. To do so, we need to identify the sentence hypothesis and conclusion by figuring out which part of the statement depends on the other. So when we look at that, our conclusion is going to depend on our hypothesis. Let's take a look at page 2. In example B, we are going to practice writing some conditionals. And if you take a look at number 1, it says that everybody at the party received a gift. How can we turn that into an if-then statement? Well, if someone attends the party, then they receive the gift. We can see that receiving the gift is clearly dependent upon attending the party. Sometimes the wordings can be slightly different. You might use a slightly different word here or there, but your hypothesis and your conclusion need to be the same. Number 2 says, get a free water bottle with a 1-year membership. How can we turn that into an if-then statement? Well, in order to get the water bottle, we need the 1-year membership. And so my if-then statement is going to look as so. If you buy a 1-year membership, then you get a free water bottle. Number 3, collinear points lie on the same line. This is an example that the book had, and I just had stated that if points lie on the same line, then they are collinear. But in fact, because this is really a definition statement, this actually would work both ways and still be true, because we could say if they are collinear, then the points lie on the same line. Sometimes we may be given a Venn diagram, and if you remember from page 1, if I think about writing my if-then statement, in order for this to make sense, we would have to say if the animal is a blue jay, then it is a bird, right? Because if we turn it around, if the animal is a bird, then it is a blue jay. That's saying for sure it would have to be a blue jay, and we know that there are other types of birds. It could be a robin, it could be a blackbird. And so in this case, my hypothesis has to say that if the animal is a blue jay, the conclusion is it is a bird. Which leads me to our next point. Our statements can have a truth value. And so the hypothesis and the conclusion of a statement, we can determine our truth value by evaluating each part of that. If you kind of dissect your statement, and if you determined that your hypothesis was true and your conclusion was true, then your overall statement is going to have to be true. If your hypothesis is true but your conclusion is not, then your statement is going to be false. Similar to above when we said, if my animal is a bird, then it is a blue jay. That would be false because it's not guaranteed that we have a blue jay. The last two are kind of unique. When your hypothesis is false, it says that the truth of the conditional cannot be determined, so it's actually considered true by default. So if I have a hypothesis that is false, no matter what my conclusion, these are going to be considered true by default. And they actually, when does that happen? It's kind of when your hypothesis is silly and doesn't make a lot of sense. That's when your statement is true by default. And we'll take a look at one of those. On the left-hand side here, it says that a conditional is false only when the hypothesis is true and the conclusion is false. So in example B, we are going to look at determining some of the truth values of their given statements. Number 1, it says if this month is August, then next month is September. Well, reading these out loud, I definitely think helps to determine if they make sense. If my month is August, that can be true. Then the next month is September, that would also be true. So overall, we're going to say that I have a true statement. My explanation might simply be that my hypothesis and my conclusion are both true. Continuing on, if two angles are acute, then they are congruent. Well, I can have two angles that are acute, but does that mean that they're necessarily going to be congruent? No. And so I'm going to say that one's going to have a false truth value. It doesn't hold true 100% of the time, and I might just give an example as my explanation that I can have a 30-degree angle and I can have a 20-degree angle, and they are not congruent to each other, but they're both acute. Number 3, if a triangle has 4 sides, it is a right triangle. Well, this is one of those kind of silly ones. If a triangle has 4 sides, that doesn't even make sense. But because this has a false hypothesis, we're going to say that this is true by default. And then finally, number 4, if x is greater than y, then the absolute value of x is greater than the absolute value of y. In a case like number 4, we actually want to try and see if we can pick some examples to see if it's true all the time, or if we can think of a case when it's false. If we're given an example when this is true, maybe when x is a -1 and y is a -3. X is greater than y. But when I plug these in, the absolute value of -1 is not greater than the absolute value of -3. And so because I can choose an example where that's not always the case, this is going to be a false conditional. We're going to talk about negating a statement. It says that the negation of a statement P, the negation of statement P is not P. And when we use a symbol to represent that, it's kind of like the little squiggle here. So negation, we're really thinking of the word not. If I look at conditional statements, I have basically 4 types of related conditional statements. The first one is the original if-then statement, and we said we could write it as if P, then Q. They give the example, if it is dark outside, then I will turn on a light. The converse is what we get when we switch our hypothesis and conclusion around. So this is going to say, if Q, then P. If I turn on a light, then it is dark outside. The inverse is what we get if we negate both the hypothesis and the conclusion. So I'm going to my original if-then, and I'm going to negate them, and I'm going to say then, if not P, then not Q. If it is not dark outside, then I will not turn on the light. And finally, the contrapositive is where we are going to switch the hypothesis and the conclusion and negate. So it's kind of like we're taking the converse and we're negating it. This is going to say, if not Q, then not P. If I do not turn on a light, then it is not dark outside. When you're given the related conditional statements, you can analyze each one to see if they are true or false. And we're going to practice doing some writing of those and then also analyzing the truth value. So we'll first look at a given conditional in example C, where my statement says that if an animal is an adult insect, then it has 6 legs. Well, up here it does say that my little science fact, adult insects have 6 legs, no other animal has 6 legs. So we know that this conditional is true. if an animal is an adult insect, then it has 6 legs. What would our converse sound like? Well, the converse, we know we're just going to switch our hypothesis and conclusion around. So our converse to that statement is going to say, if an animal has 6 legs, then it is an adult insect. Is that true or is that false? If my animal has 6 legs, it must be an adult insect. Well, again, that is always going to hold true. What if we wanted the inverse to that statement? Well, the inverse is where we go back to our original, but we negate it. So we're going to add in the word not. If I take that statement and I negate it, it says if an animal is not an adult insect, then it does not have 6 legs. Not adult insect, not have 6 legs, that is also going to be true. The contrapositive, we switch it around and we negate it. So if an animal does not have 6 legs, it is not an adult insect. It does not have 6 legs, it is not an adult insect. That is also true. So in this example, all 4 of our statements end up being true. That is not always the case. Let's look at a couple more. If we look at a statement, 2 angles that have the same measure are congruent. And we want to turn it into a conditional. That's the if-then statement. I said if 2 angles have the same measure, then they are congruent. I just added my wording in there, my if and my then. We know that that is true. What about the converse? If I switch them around, if 2 angles are congruent, then they have the same measure. That is also going to be true. What about if I negate it? If 2 angles do not have the same measure, then they are not congruent. Not the same measure, not congruent, that is also going to be true. If 2 angles are not congruent, then they do not have the same measure. If they are not congruent, they do not have the same measure. True. One more. A hamster is a rodent. How would we turn that into a conditional? Well, my conditional sounds like this. If an animal is a hamster, then it is a rodent. Is that true or is that false? If my animal is a hamster, it is a rodent? Well, that is true because hamsters are rodents. What about the converse if we switch it around? If an animal is a rodent, then it is a hamster. In this case, my converse of that statement is going to be false because this says if it's a rodent, it has to be a hamster. And we know that, well, mice are also rodents, and so that's not necessarily 100% of the time true. What about if we negate it? We find the inverse. If an animal is not a hamster, then it is not a rodent. Well, again, just because it's not a hamster doesn't mean it's not a rodent. I could have a mouse, and so I'm going to say that that is going to be false. And the contrapositive, we switch it and negate it. If an animal is not a rodent, it's not a hamster. Well, if I have not a rodent, I'm going to have not a hamster. That is going to be true. You may have noticed that my contrapositive is saying basically the same thing as my conditional. In our book, they're going to refer to statements as being logically equivalent. Logically equivalent are statements that have the same truth value. And as it happens, the conditional and the contrapositive are logically equivalent. They will either both be true or both be false. They will have the same truth value. Similarly, the converse and the inverse are logically equivalent. They will have to have the same truth value. Now, when you compare the conditional and the converse, this may or may not be the case. But you know for sure that the conditional and the contrapositive. So when I look at these here, my 4 types of statements, I know that if I write them in order, my first and my last should always have the same truth value. They are logically equivalent. And the middle 2 should have the same truth value. They are logically equivalent. Okay, if you have more questions, please see me. You can also watch the online videos that are provided by our textbook company.